Hello friends, in this lecture we will discuss about the nature-inspired algorithms. Nature-inspired algorithms are the algorithms that are designed to solve the complex optimization problems, and the inspiration behind these algorithms are the behavior of natural species. Basically, these problems are used to solve the optimization problems. There are two methods available to deal with the optimization problems. One is the deterministic approaches, and another is probabilistic approaches. The deterministic approaches are basically based on the set of steps in which for a fixed set of input the solution or output will be the exactly same in every run. Okay, they having merits like they give exact solutions, do not use any stochastic techniques, and rely on the thorough search of the feasible domains. But as with the merits, they have some demerits also, like that they are not robust, can only be applied to a restricted class of the problems. It means they require a specific mathematical modeling of the problems, like that the problem should be in a concave nature, convex nature, continuous nature, like that. Sometimes they are too much time consuming and unable to solve the real world complex problems, like the NP complete problems, whose solutions are not available for the polynomial time. So these algorithms will not be beneficial for that kind of problems. Okay, and if a deterministic approach is not available for a complex problems or optimization problems, for that problem only we apply the probabilistic methods, because probabilistic methods gives the near optimal solutions, not the optimal solutions. The probabilistic methods having merit that they can be applied to a wider set of problems. It implies function need not be convex, continuous, or explicitly defined. They use stochastic or probabilistic approaches, but these algorithms are also having some demerits, like they may converge to a global optima and get stuck at local optima. Some of the existing probabilistic methods are here: simulated annealing, random search, genetic, mimetic algorithm, ant colony optimization, differential evolution, particle sum optimization, artificial bee colony algorithm, biography based optimization algorithms, and many more. More than 500 algorithms right now available in the research scholars articles. So a formal definition of the nature spiral algorithm is that they can be defined as population based stochastic meta heuristics which imitate some natural phenomena to find an optimum solution of a problem. Here the population means a group of individuals are used in the searching process, in the solution search process. They interact with each other, they learn with each other. Basically, there is a true peer-to-peer learning among the individuals, and that learning provides that direction to the individuals to get the solution. These algorithms are also considered as a stochastic meta heuristics. Okay, here stochastic means these algorithms use previous intelligence plus random component, and these are the generalized algorithms. Okay, so the next step of the individual is decided by the environment knowledge, by the individual previous history of the states, and the previous history of the states of the individual's neighborhood. It means they learn from the society. They learn from the society. This shows that they learn from the society. So these the terminologies mentioned here. Heuristics, and the difference between heuristic and meta heuristic is very clear here. Heuristics are problem dependent techniques, while the meta heuristics are problem independent techniques. So Here we already discussed it why we use NIH as the if any. Okay, this is the very important line. If any deterministic method is available for the optimization problems, we do not need to switch for the NIA. We do not need to switch for the NIA. Of the researchers are applying nature spider algorithms despite that some deterministic approaches are already available for that kind of problems. So we should be more cautious for that. Okay, but in case if the complex optimization problems cannot be easily deal with the available mathematical optimization method, on that case we apply the NIA. But as we know that this NIA gives the near optimal solutions. This is the a simple example of the optimization problems for better understanding how we apply these nature spiral algorithms. Okay, here x1 and x2, this is the x1 square plus x2 square equals to fx. So our objective is, if let us consider it as the minimization problem. Okay, so our objective is to minimize this fx. So we have to find the value of x1 and x2 such that the value of fx should be minimum. So the unknown parameters, here two unknown parameters are, one is the x1 and another is x2. Okay, so these unknown parameters are considered the decision variables. These unknown parameters are considered decision variables, and fx is the objective function. This is the search range, our search boundary of this objective function. So number of dimension of the problem means number of unknown variables in that problem. Here we have two unknown variables, so the dimension of the problem here is 2. Okay, so the main objective function is to find the values of x1 and x2 such that the objective function fx should be minimized. So now let's suppose this is the this graph represents the global minima and local minimas of this optimization problem. Let's consider. Okay, so here one is the global minima and these three are the local minima. So the as we have discussed that one of the drawback of the probabilistic methods are is that the methods may stuck in these minima, local minima. Okay, local minima, and the swarm, the group of individuals or population may stop moving towards the global optima. So this is the basically problem exists here with these probabilistic methods. So this graph shows the distribution of the individuals in the search space, and the individuals move towards the global optima by using a step size. The step size is decided from the social influence, and this social influence is added to the individual persistence, individual's current position. Okay, we can consider it individual's current position. So we add social influence in this individual current position. Social influence is the step size basically. So this decides how large the step size will be. We can consider it as a step size. Step size. This is the step. Okay, and hence in this way we will get the new position of the that individuals. So in broadly, not specifically, in a broadly, the population based stochastic algorithms may be divided in two broad categories. One is the evolutionary algorithms, another is swarm intelligence based algorithms. Evolutionary algorithms basically are based on the Darwin's principle. It means fittest will survive, survival of the fittest individual in the next generation. The best example of evolutionary algorithm is the genetic algorithm. Okay, so old population will die out and new population will survive in the next generation. While the swarm intelligence based algorithms, in that algorithms the individual update their positions to reach at the global optima. The definition of bonobo given by the swarm intelligence is that any attempt to design algorithms or distributed problem solving devices inspired by the collective behavior of social insect colonies and other animal societies. So basically, in this lecture, we have discussed a brief introduction about the nature inspired algorithms. Thank you, friends. Thank you.